So, in the previous session, we learned how to balance a chemical equation. And now, in this session, we are going to learn types of chemical reactions. So, there are a large number of types of chemical reactions, but the ones which we are going to study in class 10th this year are, first is combination reactions, second is decomposition reactions, third is single displacement reactions, fourth is double displacement reactions, and the fifth is redox reactions. Besides this, we have got two other reactions, that is exothermic reactions and endothermic reactions. So let us make a chart, a flow chart to understand this. See, chemistry can be well understood only if the first condition is that you must be very sure of the valencies. Otherwise, it becomes a headache. So all of you who followed my instructions on day 1 that you need to learn the valencies will get a very good lead in this subject. And the ones who could not, so my first suggestion is learn the valencies every day before you go to sleep. So that is going to make you master of this subject. So, the types of chemical reaction, the first one we did was combination reaction. The second one is decomposition reaction. The third one is single displacement reaction. The fourth one is double displacement reactions. The next one is redox reactions, that is oxidation reduction reactions, and the last one is which involve temperature changes, that is exothermic and endothermic reactions. I hope it's clear to all of you. So, let us start with defining each one of them. So now I'm going to dictate the definitions. So combination reactions. I hope everyone is ready with their pens and pencils and their notebooks. So the combination reactions are defined as reactions in which two or more reactants combine to give a single product. For example, that is two or more reactants. Let us take A plus B. They combine to give a single product, that is AB. So such a reaction is said to be what? Combination reaction. What do we mean by decomposition reactions? Decomposition reactions are those reactions in which a single reactant decomposes in the presence of heat, light, or electricity to give two or more products. So what does this mean? Suppose a single reactant, which has to be a compound, is given energy in the form of heat, light, or electricity, and it breaks down into two or more products. So this is said to be what? Decomposition reaction. So in other words, we can also say that combination reactions are opposite of decomposition reactions, because in combination reactions, two or more reactants will combine to form a single product. Whereas in decomposition reactions, single reactant decomposes in the presence of heat, light and electricity to give two or more products. I hope it is clear. The examples we'll be doing when we select these topics individually. So if you want, we can give simpler examples here itself. For example, let us take A as carbon, B as oxygen. Carbon is a non-metal, but even then it is written in a monoatomic state. Oxygen is a non-metal, it is diatomic, so we write 2 here, and in the bracket we write the state also to make the equation more informative. So they combine and give what? CO2, which is again a gas. So this is an example of a combination reaction. Combination reaction is also the one which we did yesterday, that is burning of magnesium ribbon, which gives a dazzling white flame and a white powder called magnesium oxide. So magnesium ribbon was solid, it was a metal, so it is monoatomic, it is a non-metal, so it is diatomic, and it is gaseous, so we wrote it in the bracket. And here it is going to be written in accordance with the valencies and the crisscross chemical formula method, MgO. So this is also a white powder. So both of them can be classified as combination reactions. Decomposition reactions, when one reactant breaks to give 2 or more products. As we are just handling the introduction of these types of reactions, we'll take a simple example of limestone, that is calcium carbonate, which is also the formula of marble and which is also found in chalk powder, or which is also found in eggshells. So if anyone says that eggshells reacts with so and so, so who is reacting actually? Calcium carbonate is reacting. If anyone says we put acid on marble chips, then who is reacting with acid? The marble chips are calcium carbonate. So that means calcium carbonate is reacting with acid. So when calcium carbonate is subjected to heat, it breaks up into CaO and CO2. Is it clear? So this is also a decomposition reaction. Now what do we mean by single displacement reactions? We all did reactivity series. So all those who haven't learned the reactivity series yet are supposed to learn them again today. Because in single displacement reaction, we can predict the products only if we are sure about the reactivity series. So what does single displacement reaction say? It says whenever a more reactive metal reacts with a salt of less reactive metal, the more reactive metal displaces the less reactive metal from its salt solution. Do you get it? A more reactive metal. We all know the reactivity series. What were they? Kedar, Nath, Ka, Mali, Alu, Zara, Fike, Se, Pakata, है. Copper और mercury ने करी शादी और मनाई silver, golden or platinum jubilee. So let us take the example of a more reactive metal. The ones which are up above in the reactivity series are what? More reactive. So let us take a more reactive metals reaction like iron with a less reactive metals salt solution like copper sulfate. So all my students did the color of copper sulfate on the first day. So what is the color of aqueous solution of copper sulfate? Remember, we did it. It's blue in color. So this is solid iron nails. You can keep iron nails. And this is aqueous solution of copper sulfate, which we all know is what? Blue in color. And what happens? Iron is going to displace copper from its salt solution to make its own salt. That is FeSO4, and Cu will come out. We also did that all the iron salts which we are going to study this year are green in color. So the solution will turn from blue to green. Again, this is going to be aqueous solution, and solid copper is going to deposit on the bottom of the iron nails. So this is an example of change of color also, and this is an example of single displacement reaction also, just because iron is above in the reactivity series as compared to copper. So iron is more competent than copper. So iron can push away copper from its salt solution to make its own salt. And such kind of reactions are called single displacement reactions. And the reddish brown shiny substance copper is going to deposit on the bottom of the iron nails. So I hope I'm clear with the observations. So as we don't have any place left here, double displacement and redox, I'm explaining you separately. Well, I hope everyone has jotted down up till here. So, okay. So now the next one which we are going to do is double displacement. And then redox. Mind that we haven't taken up all the examples. All the examples we are going to take up when we take them up individually. Right now we are just learning the introduction of the various types of chemical reactions. So now the next type is double displacement reaction. So what does the reaction say? When the aqueous solutions of two salts are mixed, they exchange their cations to make two new products. And such a reaction is called double displacement reaction. Aqueous solution of two salts. We did the example in change of color as well. Remember, in the yesterday's session we did PbNO3 whole twice. Its aqueous solution was what? Colorless. Reacted with Ki. Again, it was a white salt, and aqueous solution was what? Colorless. Now what will happen? These are the cations. Pb plus 2 is the cation. K plus 1 is the cation. Now Pb plus 2 will go and sit at the place of K plus 1, and K plus 1 will come and sit at the place of Pb. That is, they are going to exchange their cations. And two new products were formed yesterday, that is PbI2 and KNO3. And I told you all that a yellow semi-solid substance settles down. And whenever a semi-solid substance settles down when two aqueous solutions are mixed, it's also known as, it's known as precipitate. So we'll say that lead iodide has got a yellow precipitate. So this is double displacement reaction as well as a precipitation reaction as well as a reaction which is an example of change of color. So now the next is redox reactions. Redox reaction is actually a completely separate topic which we need to understand very much in detail in full one session, but I'll just give you an example. There are redox is a combination of two words, reduction and oxidation. So what does reduction mean? Reduction means, you can note down these points, reduction means loss of oxygen. What does oxidation mean? As the name indicates, it means gain of oxygen. Reduction means gain of hydrogen. So oxidation is going to be reverse, that is loss of hydrogen. Though we are going to take it up as a complete topic when we come to it, let us do a simple example. Now, oxidation was what? Gain of oxygen. And reduction was what? Loss of oxygen. This is reduction is gain of hydrogen. This is though a very primitive method of classifying this, but then let us first learn through this. This is loss of hydrogen. So now let us see. Example, CuO plus H2 react to give Cu plus H2O. In day 1, I told you that CuO is black in color. Whenever you heat copper in the presence of oxygen, it turns into a black compound called CuO. And Cu is shiny reddish brown in color. So that means when you are passing hydrogen over CuO, it gives Cu, that is shiny reddish brown colored element, and H2O is produced. Now see, to determine who is getting oxidized and who is getting reduced, the only fundamental rule is that you look at the reactants. Never look at the products and answer, because your answer is going to always lie in the reactants. So now see, amongst the reactants, whom do you think is gaining oxygen? Who is gaining oxygen? Hydrogen is gaining oxygen and making water. So hydrogen is getting oxidized. Who is losing oxygen? Loss of oxygen is what? Reduction. So copper oxide is losing what? Oxygen. So who is getting reduced? CuO, that is copper oxide, is getting reduced. So when one of the reactants gets oxidized and the other reactants get reduced, then this is known as a redox reaction. So that's all for today. Have a lovely day today.